Welcome, everyone. Hello. I hope you're enjoying the show till today. So let's get the talk started. Today we're talking about dualities and conflicts in vulnerability management and patching. And I decided to call the talk Android Fight Club because we have a kind of parallel stories to tell. Okay, a few lines about myself. I'm the application analysis team leader at Zimperium, also an adjunct professor at UC3M, and the author of Fuzzing Against the Machine. That's a book on vulnerability research and fuzzing. And by the way, we have some copies at the stand, which will get signed after the talk at 12:45. So if you're interested, please drop by. So what do we do normally? We actually cope with many standards and regulations to actually give coverage to applications that we want to protect. So there are several of these brands that are open standards that help people actually to secure their applications. And what we do is actually taking care of complying with these standards. By the way, there is a new open source initiative backed by the Linux Foundation, which is called ADA, App Defense Alliance, which will actually reduce and simplify the way we actually can cover regulations for applications. Okay, some quick acknowledgements for my team and my company's team, and then we start. So, you know, patching is a very difficult thing to do, and I used to say that it's a kind of open heart surgery. So what we will have here is trying to transmit a concept that you should actually divide the development process from the security process as much as you can, because you need someone expert that actually has an angle on security. So now we have the parallel stories. I'm going to tell you about a few vulnerabilities in basebands, which is the chip of our mobile phone that handles all the radio connections, and then we'll go into a Flutter vulnerability. So the story is parallel because of a reason. We have a code base, we have a population of users, and software needs to be patched, okay? So the concept is the same. Either you are a manufacturer of chips of baseband, or you are an app developer. But now, what I'm gonna tell you is, what's the life cycle and what's the experience of both, and how they actually handle each other. So now, meet the Fight Club. We have on the right side the manufacturer of a potential baseband chip, and on the left side, a very easygoing developer, okay? So the way this thing may work is, okay, your manufacturer says, I fixed some CVEs, now the new release of my system is out, so the developer must make a new version. So it says, okay, I made some patches and fixes to the UI, so version 2.0 is out. Okay, then our actually manufacturer is gonna say, I have another fix, so the developer should make a new release because the operating system changed something, I had to change something. So you make your version 2.1. And then again, they say, okay, but you know, I have new vulnerabilities, and now you need to do the same. Okay, so the developer is gonna say, wait, version 2.1.1 is out. And this game could be, you know, very exhausting for both parties, not mentioning the users themselves, which need to stay, you know, behind this game, which means follow the updates of the application, follow the updates of the operating system, eventually of the firmware, and whatnot. So, you know, it's a kind of chicken egg problem. I also put version 2.1.1.1 to actually stress this concept. Now we actually try to transmit what happens when a vulnerability is out on the media, okay? If you have an app vulnerability, it's very easy. You're gonna see headlines like this, okay? It's a critical thing. We're actually talking especially about this vulnerability, and everyone will talk about it. So you're going to see some coverage in the media about this vulnerability. because it has high impact, because it's critical. So there are many, many things which actually hit the news in this case. And in this case, the WebP, it's Flutter, so Flutter is iOS, is Android, multi-platform, also it included the browser. It made a lot of noise. And then immediately we go into a baseband vulnerability, and you get this kind of effect in the news. It's a kind of picture of a black hole, you know? Have you ever heard of a baseband vulnerability, critical baseband vulnerability? No. And I have a partial explanation, which is, okay, I mean, system internals are very, very hard. If you think about a specification of a communication protocol, that's probably all these pile of books entirely. Okay, it's thousands and thousands of pages, and also it's very difficult to program them correctly. So the software may have some problems, and there is also something which is called interoperability, which is tough per se. Okay, so I have an example here on how you could exploit a baseband vulnerability with a particular call. You saw on the left, there was a small base station you can actually call, and you'll see here something very curious, which is crashing the baseband of the phone, okay? So this is a message that gets sent to the modem, and you get a crash, okay? So this thing actually may lead to a complete exploit chain of your device, and you may not even notice that it's happening. So it's a critical vulnerability, and the way it's managed is quite hard, you know? Actually, to be honest, in protocol fields of communication, there is a field which is very, very peculiar, which is called tag length values, where you basically send a radio packet that includes the length of the packet. So if you can actually are able, sometimes, in many times, many vulnerabilities of this kind, they just ship a size which cannot be handled by the protocol in the device, and they make the baseband crash, for example. Okay, that's the farthest technical I'm getting, but it was just to transmit you the idea. So now, how a manufacturer manages these vulnerabilities? They have kind of bulletins, okay? That's MediaTek, one of the producers of baseband, and they tend to give you credit. So in my abstract, I cited these vulnerabilities because Daniel Komaromi has a very nice blog where he explains in very, very deep details how could you get advance of some vulnerabilities and understand. So, and also Samsung has the same. So now we go back into the manufacturer path and how is going to handle such vulnerability. So now you are in a particular piece of your phone, which is the baseband chip, okay? And you have to deal with the AOSP, which is not part of that thing. But you may release your patch within the AOSP newer version when it's ready. So when you do this, your chip may be in several brands of phone. So you need to deal with all these guys. And last but not least, you need to deal also with the carriers, because if you modify the baseband, something may go wrong with the connection. So hold on, right? But now, the interesting part is what happens to the user or developers. So I figure somehow that they are in a kind of hostage situation because they are actually held by this perspective, okay? But nonetheless, the way you handle patching, it's very straightforward somehow. You have a timeline, okay? And before the vulnerability is actually discovered, you are in this situation, okay? You don't really know what's happening. And I'm gonna tell you a secret. Whatever phone is in a store right now either has a 0 day, but if it's actually older than a date, it contains vulnerability which are actually well known. And if you don't patch it when you buy it and open it, it's gonna be vulnerable, okay? Then when you have the patch, you'll be empowered. But you have a problem. You don't have control of your population to understand what happens with the patch. Are the users going to patch or not? That's a kind of a mystery, you know? So, well, you know, the situation is kind of mixed because you have now people with Flutter, Android, iOS, and all these brands. And you know what happens? Sorry, there is something over there. Can you check? Can you check what's going on? Like, yeah, you know, what happens, guys? People get distracted by these kind of events. The media, everything. But in the end, the message is, hey, you should patch. Or not. Because patches may introduce new vulnerabilities. Actually, bad actors, which are not eager to read the entire specification of the protocol, what they'll do, they will look at the patch and try to understand from there, from the pinpoint, the entire thing. So yeah, until now, this thing we understood is quite painful. And by the way, if you are a manufacturer, you don't have a real way to understand what's going on with the population. So if you think about it, it's a kind of a black hole because you don't know, you don't have access to the stores, you don't know how many people buy your phone, which version do they have. Once they are on the stores, you basically get out of control of the population. And of course, as I said, you're going to have devices which are already there since a few years, and when you buy it, it's already vulnerable. That's why you cannot only rely on patches. So the deal with manufacturers is that they don't know about their population, while developers do, because you have the numbers, right? You know many downloads, you know many versions, so you are kind of in a luckier position. The way a manufacturer can actually understand what's going on is through the sales. Okay, you can actually try to say, okay, we sold this amount of unit, this model. You can try to make an estimation, but you don't know if it's connected to the network. You don't know if the guy is taking care of it or not. And of course, as I said, you always need to deal with all these players together. So as I said, developer's life is kind of more relaxed. You have a fixed number of users. They may increase or decrease. You have control over your population, and that's something really, really cool because of two reasons. The control means you can actually remember what happens. You know, you can actually get a history of the things and say, okay, when I released this thing, which was critical, it happened after a few months that X, Epsilon, and Z. So that's actually pretty good as a developer perspective. So now if we move into the other part of the story, which is a Flutter vulnerability, you're going to have this kind of scenario where you have a multi-platform, multi-code-based, single code-based multi-platform application with one caveat, which is if there is a vulnerability in your one code-based multi-platform, it's likely that it's going to hit multiple platforms. So that's actually what is going to happen and what happened with this WebP vulnerability. You had actually iOS and Android involved into a single code base. So the urgency for patching actually happens because of a reason, because basically this particular vulnerability consisted in one image, which could be actually be sent to a program that had this library. It basically played with the internal of the system. There was a buffer overrun, and you could get, let's say, simply a root access. The problem is you can get massive exploitation of this, so you can compromise a lot of users. That is why there is a lot of coverage. While if you think about the experiment of baseband, that requires a lot of detail and a very, very tailored objective because you cannot make it scale. So now you see the two perspectives. A developer problem is they may be hit by a massive vulnerability escalation, while the baseband requires a lot of expertise to be exploited. So the coverage maybe is actually linked to this concept. So yeah, the idea is that we want to avoid this kind of effect. Okay, so now if I go into the detail of the WebP vulnerability, it's actually pretty nice because on September 7, they basically said, okay, this is a vulnerability which is actually getting exploited, and a few days after, like 12th of September, which was disclosed, you have 13, there is a patch available. And by 1 month, all the top players, they had it patched. Okay, and our question was, what do we do? Like, okay, if the top players are patched, can we go and rest for the rest of our life? And the idea is, let's check what the others have done. So how did the rest of the population of Flutter application actually perform? So by the end of 2023, we got 8K app random sample, 1% in Flutter. Of this 1%, 90% was vulnerable. So this is from September, when it was disclosed, by the end of the year, random sample of application. Now, if you go to the beginning of the year, that's a new random sample of application, same density of Flutter, and you get 60%. That's not even half of the population after 3 months. So now the problem is on the developer side. The patch is out. It may or may not know the problem. It may or may not update Flutter. It may have some constraints we are not actually aware of. So it's a kind of a void space. Now there is also another interesting thing. If we actually go about Flutter-only application and we take a 1K sample, in 2023, 10% was vulnerable, but in 2024, it actually increased. So this is actually looking weird. And I have few partial answers. One is the number of Flutter applications actually increased in general in the Play Store. There were like a 25–30% increase. That's a possible explanation. And then there is another one. People get interested into this technology, so they may just basically get a tutorial, okay? And the tutorial may be 6 months old, saying, just check out this version. So you just do it, publish your application, and it comes with a candy within, which is the vulnerability. So it's very difficult to understand this thing. But I'm not finished with the developer story, you know, because now I wanted to understand what's going on with our devices. So what's the probability for us to have a vulnerable application? So there are a few studies. We actually have an average of 80 applications on every device, okay? And then we have more than one device. So globally, they say that people have 3.6 devices and connections per person. North America and Europe actually look like people have 10 devices. So you have a kind of this effect with the idea, more or less, that 1% of your application is vulnerable. So basically, one device, one application. But if you have 3 devices, you can actually make the numbers yourself. So that starts to be quite of a juicy thing, because if someone wants to try to exploit massively, he has a good probability to catch someone, you know? The fact that you have Flutter doesn't mean you'll have a possibility to exploit the vulnerability, but the fact that everyone has at least one application with that increases the surface. So yeah, as I was saying, more devices, more vulnerabilities. So patches are not the only and unique solution to actually solve this problem. What you would do is actually rely on other indicators, for example, anomaly detection. So you can observe things that are happening on the system. It could be from battery draining to network consumption that may vary and may indicate something that's compromised on the system. So we actually provide these kind of solutions also through code analysis and best practices and standards. Why? Because the standards have the habit of actually reducing the surface in a methodical way. That's what happens with aerospace. They have protocols that they strictly cope with because they know that percent of success will not decrease. So it's going to be 99.9999, and you want to keep it actually that way, so you keep the protocol. That's why the standards are there to actually help us. And you need also to think that in this entire process, if you actually forget about the weakest ring, that's exactly where they are going to hit you. And now the problem of a developer is like you have a device with a lot of sensors, a lot of service, a lot of exposure. So that's actually pretty difficult to handle all this. That is why we were forcing somehow to say you should separate development and security because you are coping with a lot of things. It's more than a computer, you know, it's a computer with a lot of sensors. So now, imagine you are developing your application that's free PDF, QR, ebook, music. The probability you self-inject a vulnerability in your application, it could be pretty high if you are thinking only about the output of the application. Like, I want to do this thing, and I'm going to get Flutter. I get a tutorial, and I do it. It works. Great. I publish it. And now what? So that's the idea, right, that I want to transmit. So basically, the development cycle and the security cycle could be explained into these 3 steps. So you have the development part, and we can actually provide you solutions for that. Then once you publish, you do not want people to reverse your application, so you need also some solution for that. And when you are on the end device, well, you know that people may jailbreak their phone or basically root their phone and change something and maybe get some of your IP. So the idea is that to separate this process with development users and malicious code, you need some expertise, experience, intelligence to actually help developers to do their job properly, so to deliver what they want. And on the other side, what you want to do is actually help people to stay safe and avoid massive exploitation. So we are getting to the end of the talk, and I want to leave you with a few takeaways, which is, okay, it's easy to develop an application for mobile. In a matter of few hours, you can get an application done in Flutter. Now the question is that safe? Is that good? So it's very difficult for a developer actually managing both parts. So that is why you should trust some experts. And actually, because the experts basically have already digested this kind of stuff, so they can help you with the surfaces. So as I said, this is a difficult thing. And we actually strive for separation between development and security. So please, if you're interested, drop by our booth 16, 12:45. We have a signing event of my book. And last but not least, I have an update for the pins. So take a picture of our booth, post it on social network, and the most like will win. We don't have only one, so thank you. The stage is open for questions.